Hi everyone, I hope everything is well on your side, and today I'm bringing you the Hashgraph consensus algorithm. It's explained by Dr. Lemonbed. Now I'm just going to do this video just for the algorithm, and we will be talking about the other features of the coin and HBAR in another video. So here we go.
Hello, I'd like to talk to you about how the Hashgraph consensus algorithm works. Suppose we have a bunch of computers, we'll imagine 8, that are named Alice through Hank. So Alice has a transaction she wants to send out. She puts it inside of a message, and that message she sends out by using a gossip protocol. This means she sends it to a random person, and then each of them sends it to a random person, they send it to a random person, and exponentially fast it explodes outwards, and the whole world knows about it. Now, what if Bob and Carol have transactions they want to send? Well, they put them inside of messages, which they then send out to random people. So there are 2, then 4, then 8, and it blows up exponentially. But how do we know what time each message reached the world as a whole? Well, we could keep track of when each person received each message. And we could take those times. And we could sort them, all the times for the red message, and so on. And then we could take the middle of the list. This tells you when the red message reached most of the world, and when the blue one did, and when the green one did. And if we sort the messages by that, that puts them into a fair order. So now we have them in order. Oh, but wait, how do we know when each person received each message? Sounds like you'd have to send out a lot of receipts. No, we'll send no receipts at all. Here's how. When we're doing our talking, we can draw this graph of how we talk to each other. Alice talked to Dave, so we draw a line from Alice to Dave, and then they talked, and we have 2 more lines, and then more, and then the blue and the green come into our graph, and then they spread and spread and spread. And the result is this big diagram of how we've all talked to each other, this graph. But we could create a message for every circle in the graph. It has whatever transactions you want to create. It has a timestamp of when you're claiming that you're creating it. It has your digital signature, and it includes 2 hashes. A cryptographic hash of the last message you made and the last message you received. And just by adding the 2 hashes, it ties them all together. And so we could actually store this graph in memory on every computer, and we would all know the complete history of how we talk to each other. We're not just gossiping the transactions. We are actually gossiping out indirectly this graph itself. We're gossiping about the gossip. We are actually talking about how we're talking. And once we all have this hash graph in memory, we can just look at it and do virtual voting, which means we just look at it and we know the timestamp of when each person received each message. We don't have to talk to each other about it. We don't have to send out additional messages about when you received things and about what orders to put things in. You get it for free. Virtual voting. So, how does Hashgraph consensus work? We want to put the transactions in order. How do we do that? We'll sort them by the order of the events. But what's the order of the events? You just sort them by the consensus timestamp for each of these events. But what's the consensus timestamp on an event? It'll be the median of the received time. It'll be the middle of all those times of when it reached everybody in the world. What's the received time? Well, it's when an active computer, an active node, received it. The computers that around that time were each sending events to many of the other nodes. But what do we mean at that time, sent events too many? Well, we mean during that round. We all have this history in the hash graph. We break up history into a bunch of rounds, and we just look at it and say, okay, during that round, did this node actually send out some events? If they did, they have a famous witness. And did it reach many people at once? If they did, we call that witness famous. And we will weight all of this virtual voting by the stake that they are holding, how many HBARs they own. So, it is gossip about gossip with virtual voting. And that is the Hashgraph consensus algorithm.
Well, I hope that's been informative to you. I look forward to hearing from you about what you think about this video and about the algorithm. I'm out.